Questions you got?
I take yellow though.
So today is kind of a build on yesterday. I'm adding one little thing, but we're still solving triangles. So just, yeah, that's what we did yesterday. Yeah, which one? Which one you want me to do? 12? Okay, number 12.
No, I didn't.
Yes, you did.
I didn't say no till Friday. You said we have a quiz Thursday, and I was like, no, we have a quiz Wednesday.
Yeah. My bills are paid. I pay my bills are paid. I don't know what it might be in my unless they tell you to change it, I don't get it.
Yeah, we're probably having a quiz tomorrow.
I understand this.
Solving triangles.
I don't understand the thing we learned last week that I needed the homework.
So your last quiz went up through the trig practice, so this one would just be solving right triangles and special right triangles. All right. All right, listen. All right, so here we go. We're solving this triangle, so we're finding all missing sides, all missing angles. So the easiest thing to do, because this one's given me two sides to start with, is I'm going to go ahead and jump into the Pythagorean theorem. So 12 squared plus b squared equals 19 squared. This is 144. What's 19 squared? Somebody, anybody? Everybody scream. There's squirrels in my pants. Okay. What? Who does? What's 19 squared? Thank you. Minus 144. What is it? What's 361 minus 144? So this is just the square root of 217. I'm going to leave it right there. And now I'm going to find my theta. Yeah. That's fine. That's fine. This theta, based on this theta, I've got the adjacent and the hypotenuse. So what trig function uses adjacent and hypotenuse? Cosine. So the cosine of theta is 12 over 19. Why did I use adjacent and hypotenuse? That was what was given. I always want to go back to what I was given and work from there. So now how do I get theta by itself? Inverse cosine on both sides cancels it out over here and causes me to have just the theta. So if you put this in your calculator, making sure you are in degrees and not radians, what do you get for your theta? 50.833. Were you in radians and not degrees? That will do it. So this is 50.833 degrees, which means this last angle, 90 minus that, which would be 39.167. Whoa! 167 degrees. Yeah. Second cosine 12 divided by 19. Right. Yep. Yes. No, you don't have to. Yes. Subtract it from 90. Oh, good. Thanks. Now we'll have some if y'all start bleeding. All right. Let's do elevation and depression because this is the same thing. We used to have a class called Algebra 3, and I used to teach it, and we did a project with angles of elevation and depression. It was a really cool project, but we don't have time anymore. It's really time. They're all kind of the same thing. What? I don't know. I cannot get it to a nice, comfortable temperature in here. I know. All right, angles of elevation and depression. Here's what this means. All right, y'all ready? Ready, puzzle people? Angles of elevation and depression estimate distances for us of various kinds. And let me show you what I'm talking about. So here's what I always think about whenever I think angle of depression or elevation. Imagine, who's the superhero whose eyes are lasers across? No. He wears like glasses like this, and if he takes them off, he. Yeah, he's in the Marvel movie.
That turns people to.
Y'all, oh my gosh, y'all don't watch movies?
It's Superman.
No, this isn't a Marvel movie. He wears like. No. Is that his name is Cyclops? I think that might be his name. And he takes the thing off and it makes him, it just lasers out. Okay. Regardless, imagine. If you want to. All right, imagine with me, if you will, that whenever you look out across, there are lasers that come out of your eyes that make a line that is parallel to the ground as you come out. It's this laser that shoots out of your eye, okay? Now, if you look up at something like, let's say there's a mountain or something that you're looking up to the top of, from that laser up to your eyes going to the top of this mountain goes up here. This is an angle of elevation. It's when you look up at something is what it is. But the angle, your actual theta, happens if you look straight out across, it's parallel to the ground, and then you raise your eyes up to the top to look. That angle that forms, that's your theta. I'm standing here, and I'm looking up at the top of the ceiling up there, right? The angle of elevation that I am creating, if I drew a straight line straight into the board like that, and then I drew a line from my eyes up to the top of the ceiling, this angle, this choop angle right here, that's my angle of elevation. Does that make sense? Right. So, like, we did this project where we would stand so far away and we would hold a protractor, and it was a weighted one with a string on it, and we would hold it at our eyes, and as we looked up, it would measure the angle that we were looking up from. So it's a little homemade one. Anyway. That's your angle of elevation. Tyler, you're right. Sometimes you're looking down at something, right? So if you look down, like maybe I'm looking down at the base, or maybe there's a, I don't know, maybe there's a Grand Canyon down here. And you look down at the base of the Grand Canyon from where you're standing. This, I'm still shooting straight across. This is my theta, and it's my angle of depression. And so what happens with these angles is that they form right triangles, okay? So here's this right triangle. Here's my angle. I come down, I drop down. Look at this right triangle right here. This triangle looks like this. Here's my right triangle. Do you see how I can make right triangles out of my angles of elevation or depression? No?
am.
Okay. For instance, Leia, this is for you. What's the tallest thing you saw when you were in Boston? Right, name something. Doesn't matter. The state building. All right. I don't know what it looks like. That looks looking like.
Big little dome on the top.
Well, I thought it might be a dome. It's in New York. Where did you think it was?
Yeah, that's where Buddy went.
Okay, go.
Malaya, this you. That's you. Okay. You're looking up at the top of the, what's it called? The state building.
I don't need help no more. I don't need help. I'm angry now.
All right. I want to estimate the height of the state building. Okay. Now, Malaya, how tall are you? 5'6". In inches, that would be what? Let's just say 5.5 feet. Okay. Here's where this comes across, right? I want to know how tall that building is. Now, here's my right triangle. Let's say you were standing 50 feet away from the base of the building, and you were looking up at an angle of 27 degrees. That's your theta. Your angle of elevation is 27 degrees. You're standing 50 feet away from the state building. How tall is the state building? This now it has become, it is geometry. That's exactly right, Will. That's exactly right. All right, so all I got to do is find the other side. Here's the other side. And once I do, I have to add that 5.5 into it for her height, right? So how am I going to find the other side, first of all? You don't even need the other angle. What do I have? If theta is 27, I have adjacent. This is adjacent. This is opposite. What deals with adjacent and opposite? Tangent. So the tangent of 27 is going to equal opposite over 50. What is the opposite side? Multiply by 50. 27 times 50 would give me that opposite side, and then I have to add in the 5.5. So 30 point. Three places. No, go up three. Yeah, go up three. That's it. Okay. 9 times out of 10, these are going to be tangents because you're not finding the hypotenuse. Yes, this is what we're learning today. Yeah. Yeah. It's kind of, but it's word problems. Yes. Right. I'm going to do one that's very similar to one on your work today. Always draw a picture for these. The angle of elevation is given at 27. Harris No. Harris goes to a hot air balloon festival. Yes, Harris. Here's Harris.
Say my name.
There's you, Harris. You like your hair? Okay. Here's Harris. Harris is at a hot air balloon festival. He spots a balloon due east.
No.
Okay. He spots a hot air balloon due east at an angle of elevation of 27 degrees. What's my how do I draw my angle here? He's looking up to the hot air balloon and lasers out of his eyes this way. So this is 27 degrees. Yes? Okay. Then he turns the other way and looks. He actually just stands like this and looks this way and this way. That's the way his eyes are. Okay. He looks this way. He sees another hot air balloon over here. Harris, how many hot air balloons are out here? It's a festival. To make the stripes good. Okay. He turns west. He sees another balloon at an angle of elevation of 13 degrees. So again, not drawn to scale.
Yeah.
If the altitude of the balloon, the first balloon, now what's altitude mean? The height. And we're going to say Harris is 2 meters tall. 6 foot. 3 meters and a foot. 3 feet and a meter. So that'd be 6 feet. Is that how tall you are? Okay, close enough. Be easier to look at. Okay, so Harris is 6 meters tall. The first balloon is 200. Oh, 2 meters is 6 feet. Yeah. The altitude of the first, so all the way down to the ground would be altitude, right? Because here's the ground. There's grass growing. Okay. It is looking a mess, but I want you to understand where these numbers are coming. The whole entire altitude is 250 meters. That's all the way the altitude. The altitude of the other balloon from here all the way down is 500 meters. It is. It's not drawn to scale.
But how about the angle?
How far apart are the two balloons? So in the middle, you're exactly right. So how far apart? We're going to assume Harris's head is 0 meters. How far apart are the two balloons? So what is that? That's all of this is what I'm looking for. Look at the red. Look at the triangles that I have. Look at the I've got, here's a triangle. Here's a triangle, right? We don't have the middle angle. But look at this, because you have to be able to visual. That's why I said you have to draw a picture for these, even if. That's exactly right. That's exactly right. We can just find this length. And this length, and add them together, because if I
Wait, okay.
That's how it sounds out.
So we're adding.
all right, so now that you know what we have to find, but wait, look at my triangles. What am I not taking into account right now? I'm not taking into account Harris's height. So look at my triangle. Look at my triangle. Yes, because the whole altitude all the way to the ground is 250. So my triangle, though, stops right here. So I have to take his height out of it. So this would be 248 meters. And this would be 498 meters. Because the 500 is all the way to the ground. It doesn't matter. Doesn't matter.
I'm not 6'5".
We're going to find those values that they are apart.
I looked at the list, but I didn't see my name on it. So I didn't bring it.
No, actually, you're 6'5".
I think it was the meeting with that.
Lane. For that meeting, how many districts in it? Where they signed up the big stuff? So there's one here to sign up for it. Probably not you. Sounds like a deal.
All right. Yeah. It's what? What's 140? The middle side? Oh, I don't need to know that, though. You could if you want. All right, so look, Harris, let's work on the first triangle. We need to know how far apart these are. You're standing there looking at them. We need to know, right? All right, I'm going to look at the purple triangle first. This one right here on the side, on the right. So this little triangle looks like this. This is 27. This is 248. Find this one. What are tan? 9 times out of 10, you're using tangent on these. So the tangent of 27 equals what? Over x. So this is where what we did yesterday, right? I'm going to multiply by x on both sides and divide by tan 27. And what do you get? 126.362. Approximately. That is this side right here, which means if that's this side right here, that is also this distance. Well, oh, what did y'all get?
I got 486.
All right. 486, what? 675.
Oh my God, what is going on?
Somebody give me a calculator.
Bro, what's going on? Yeah, it's 486.
286.727. Look, I know, guys, listen, I know this seems like a lot, but the problem is you have this is literally just a paragraph, and you have to figure, that's why I'm taking all this time to draw the picture and stuff, because it gets hard to wrap your brain around it. Yeah. You did 248 divided by 1027. That's because you rounded the 1027. That's why your rounding's off. That's fine. That's fine. Huh? The rounding could be off some. When I put this in the calculator, I said 248 divided by 1027. You can do that. Yes. Yeah. Because I had to multiply by x on both sides to get x out of the bottom. And so then whenever I have x 1027, I divide by 1027 to get x by itself. We're fixing to do it again on the other one, and all right, look at the other one. Shh.
How do you get to the home button?
That's Kenzie! Don't lose her plate! Where did you get that?
Right there.
Oh my gosh.
Wait, isn't that?
A Kindle?
Yeah. Yeah.
Yeah, and you're letting her do that?
I didn't let her do that.
It was sitting right here on the desk.
I didn't see it. Okay. Now, this side, right? Same thing, I'm going to use tangent. So tangent 13 equals 498 over the variable. So same song and dance, right? I'm going to multiply by x on both sides. Tangent 13 equals 498. And now divide by tan 13.
That's why I thought, because the 9 rounds of that last.
All right. What'd you get? What'd you get? 2157. Oh, so, and then we add the two together. So, how far apart are the two balloons? 2,600 what? Meters.